I'm an artist and a software engineer combined in one. I try to make the world a bit more visual, usually with illustrations, but once in a while I actually need to do something related to my daily work. I did my master's thesis on data visualization several years ago, and with the help of that research and my own experiences at work, I will tell you why you should focus on data visualization and how you can do that with your data from test automation. Because all test automation tools and frameworks have one feature in common. They all create a report at the end of the execution to tell you how that execution went. Regardless of what tools and what frameworks you're using and what you're testing, you always get this report. This report contains the basic information, the test case names and their results, but usually they contain a bit more elaborate information, as is the case with Robot Framework. The Robot Framework log file contains, in addition to the executed test case names and the results, for example, the keyword execution times and test and suite execution times, any errors and log traces for your errors and even screenshots and videos, and some statistics for tags, suites, and tests, and so on. And this is all before all your custom metadata, custom logging from your own keywords, Robot Framework keywords, your custom listeners, and whatever you call. The log file is a fantastic tool for short-term data analysis and debugging. The log file automatically collapses all the past keywords and past test cases and opens up only the failed keywords and test cases so that you know immediately where your test failed and where it failed. However, things get more complicated the minute you get your second log.html file. Because now you're not only comparing results with the expected behavior, but you're also comparing results with the previous results. So for example, the test case that failed previously, has it been fixed? The test case that failed now, did it fail previously or is it a new failure? And so on. And this just gets more complicated the more report files and more log files you add into this equation, and this is where visualization comes in. Visualization is the key for data-driven decision making. And this just means that you are making decisions and taking actions based on data that you've stored. So not only just reading the report file once and then throwing it away and hoping to remember it at the end of the day or end of the week, but you actually need to store it. So in the case of the little friend, our hobby here, she has a pantry full of food. So she doesn't always want to go to the market to buy the food. She stores some food in her pantry so that she can access that food whenever she wants. But just storing that data is not enough, because you also need to see your data. If you just store something and never use it, it will eventually go bad. So if our hobbit never goes into her pantry and just puts more food in it, eventually some of the food will go bad, and it's not good for anyone. But just storing and seeing is still not enough, and you still need to understand what that data means. So, for example, the hobbit takes her food out, lays it on the table, but she needs to know what sauce goes with what, and doesn't want to present all the food at once, and actually needs to understand what it is that she's eating. Well, that's the basics of data-driven decision making. And what do you need to actually make data-driven decisions? Well, luckily, the answer to that is very, very simple. You only need 3 things. Well, tools, things, items. I'll just call it the list of 3. So you need a list of 3 things. First, and hopefully you all already have this, you need your data, which in this case is your test reports. Without data, there is no data-driven decision-making. There is just decision-making. So you need your test reports, you need your data. Then you need your pantry. You need a place to store your data, so a database. And finally, you need somewhere where you can actually see that data. So you need a visualization tool. And in the case of our Hobbit, you don't want to present all your food at once. You actually need to present just the first course, the main course, or desserts at once. Because if you present all the information at once, the viewer will suffer from something called information overload, which basically means that you are presenting too much information so that they cannot understand what it is that they should be looking for. And of course, when talking about information overload, the best example is obviously Sauron, Lord of Middle-earth. Everyone knows that Sauron wanted to dominate all life with some magical rings, but only a few people know that Sauron initially wanted to be a data scientist, and he wanted to make the perfect graph that would solve everyone's problems at any given time, so that anyone in Middle-earth could just glance at that graph and get a perfect understanding of what is going on at any given time. Unfortunately for Sauron, all the races of Middle-earth were interested in different data and preferred different visualization forms. For example, elves, as they are immortal, they wanted to see centuries of data at once. They were not that interested in the last few hours. They wanted to see centuries of data. They wanted to see a long period of time so that they could understand the big picture and the trends, how things have evolved. Orcs, on the other hand, they were not immortal, and they wanted to see heat maps of all the fights going on in Middle-earth so that they could join in the fight as quickly as possible whenever they wanted to. Dwarves were not that interested in the visualizations themselves. They just wanted the raw data. They wanted loads and loads and loads and loads of data so that they could do the data mining themselves and identify what are the actual gems there. And of course, the minds of men are easily corrupt, so they could just roll on with anything Sauron threw at them and pretend that they understood what that data means. Now, even though this example is a bit humorous and slightly out of this world, the same principle applies to an actual software project. Because every role in an organization is interested in different metrics, and they need different visualizations to understand those metrics, and they need the different metrics to make the best decisions for each problem, for each situation, based on their role. So, in other words, your visualizations need a target audience. So who is this visualization for? There is no one graph to rule them all that you could just give anyone. You actually need to focus your audience. And your visualization also need a purpose. So what is the problem this visualization is trying to solve? Why does this visualization exist? What information is it trying to convey? So, how do you make the correct decisions? Let's assume I've sparked someone's interest, and you install your database and your visualization tool. What then? What do you visualize, and what do you look out for? Well, I've divided this into two categories. The first category, anomalies. And this means all unexpected events. So the most obvious example is that you're expecting a test to pass and it fails. You notice it immediately, and you can take an immediate look at the log file and see where that test failed. The log.html file is very good at this. Not always, but usually it is the best tool to use for this. But the one category where the log.html file is not that good is consistency. And this means, for example, that do the tests fail in the same way every single time, the same parameters, same phase? Do the tests fail in the same part every single time? Or something that is more subtle, is the test getting gradually worse? Or is the system getting gradually worse? So in terms of like execution times or resource allocation, is something gradually getting worse. I'll give you some examples from my previous projects. The first project is from embedded systems, and the second project is from telecommunications. Now, before I jump into these projects, you remember the list of three. Our list of three was robot framework, obviously, as our test data. I would not be making this video if it wasn't for robot framework. Our database was InfluxDB, which is an open source time series database. And our visualization tool was Grafana, which is an open source data visualization tool. Now, these are the three tools that we used, but this is nowhere limited to just these three. You can use whatever tools you're using currently in your project, well, as long as they fill your needs and do what you expect them to do. Well, without further ado, the first project, embedded systems. So the project in general was there was many different components, and we made some tests for those components. A lot of components developed individually, and our team's responsibility was to collect those components, run test automation, and then generate a report to pass on the next phase of testing in a case that a certain percentage of those tests have passed. Now, this whole project was not yet in production, so some flakiness was allowed, but usually things went smoothly and the pipeline worked just fine. The general pipeline flow was as follows. So we take a look at the devices or the software for the devices, check for any possible updates, update the devices, run our tests, then if the tests pass or the threshold has been reached, then create a report and pass it on to the next phase of testing. Usually, things went just fine. Occasionally, we got failures. There were no devices to update, the test failed to run, and so on. But usually things went just right. Now, our schedule was to be run once a week, every Sunday night, so that every Monday morning we came to work and we got a fresh report to see did anything need to be done. And this goes on for several months until we hit the inevitable. And we failed to meet the threshold. Twice. Now, occasional failures had been allowed. It was flaky, and usually it was some sort of compilation error, and the developers would then redeploy a fixed package a few days later. But then we failed to meet the threshold twice in a row, and still more. Now, this is very uncommon, and we were starting to get worried, and even our test manager started to get a lot of pressure from above because the next phases of testing had caught up with all the work, and they were sitting idle waiting for our report. And in that case, our test manager said something very alarming, at least in my opinion, and he said this: could we just ignore the failed test cases? We could agree that 100% of the test cases that have passed, so could we just go with that and ignore the failed tests completely? Oh, well, let's put a pin on this and come back to it a bit later on, but first I'll explain what we actually did. In hindsight, our solution was very, very simple and very obvious. But in that situation, it was not simple and it was not obvious, and we really struggled for this a while. And we did this. We created a simple table that showed only the test case names that had passed in the previous run. We tried to create a table that showed how many times each test case had failed consecutively, but we couldn't get the query working just right. So this is what we came up with. And then we could change the time frame to see how many tests are reappearing in that table as we scroll through time. And indeed, we did notice that several tests have started to fail 3 weeks ago, even though we knew they had been run previously, but they started to fail 3 weeks ago and they had not passed since. We took a look at the specific device and noticed that the feature is nowhere to be seen, or the group of features. We took a look at the gyro tickets, there was nothing, and finally we asked the developers, why are these breaking? And they answered that the feature group had actually been some sort of wireframe, that it had been taken out, refactored completely, and it's still under development. There had been no communication about this at all, and our test automation assumed that that feature is still in place. So let's unpin the question, could we just ignore the failed test cases? Well, in this case, yes, we could, because those features were not supposed to be tested anyway. So we just added a work in progress tag to those test cases so that they were no longer run with our CI/CD pipeline. We reached a threshold and generated a report. We also lowered the threshold a bit, but added a big warning sign to the beginning of the document unless the original path threshold was not met, that, here's the package, feel free to test at your own risk, but test automation failed. So what's the moral of this story? Why did I tell this story? Well, the first moral is that communication is important, or it's essential. When you have more than one person involved, communication is vital. Speak up, talk to your peers, talk to your colleagues. It helps a lot. And the second moral that actually relates to data visualization is that even the simplest visualizations can have a huge impact. And if you just make a visualization, you will get more familiar with visualizations. And then later on, when you've already done some visualizations, you know how to make better visualizations. Well, let's move on to the second project, telecommunications. It was a large, safe organization doing an application on top of Salesforce. I belonged into the system team of that safe project, and our job was to keep the Salesforce environment alive and do test automation, keep the integrations working, and so on, do deployment automation, and so on. Now, do you know that the allocation for test automation was very poor in this project? We were not able to properly maintain and develop the test automation framework, so trust for the test automation has gradually gone worse. The general flow of the pipeline was as follows. So developers made some changes in their development environments. Then we would move on or deploy those changes to pre-production and other testing environments, and finally to production. Now, typically this worked just fine, as with the embedded systems project, until one specific feature was made, or one specific change. It was a large refactor on one specific flow of the whole system. It was deployed to the development environments and until pre-production, until the huge issue was found. And the issue was the performance was so poor that the test execution times just skyrocketed. We raised this concern with the developers and architects, but we were dismissed and overlooked as, test automation is broken anyway, and it's just a temporary network issue, and so on. It was not until the other testers and developers started to complain that it is actually unbearably slow. So the developers started to wonder, could they actually have done something wrong? But there was no way to prove that. So what we did was that we created a very short test case that ran for a few minutes, every 10 minutes for a week, every single day, and every single time of the day, and gathered the execution times of specific keywords. In here you can see some lines on the bottom, some lines on the top. They all should be roughly the same. They're just basic wait until page is loaded sort of keywords. And they all should be in the relatively same area at the bottom of the graph. Well, we did not know whether this was the case or not, so we ran our test cases and we were able to prove that this was indeed the case, and it was not a temporary network issue, and it was a consistent performance issue in the system. Now the developers and architect could no longer dismiss this issue and overlook it, and they actually needed to focus on bringing the performance back on track. So they did just that. They made some effort and they got the performance back in line so that the site was usable again and everyone was happy. Now, what's the moral of this story? Well, keep your tools maintained, keep them usable. It increases your trust in your test automation, and when you start to lose trust, it's more difficult to regain lost trust than to keep up your trust. So keep your test automation relevant. Allocate resources to your test automation development. And the second moral is that time series data and time series graphs can help you identify and even prevent issues. Now I've shared my two stories. Then what do you do when you get home? Well, you should prepare yourself. I've mentioned the list of 3, so hopefully you already have the most important thing. You all have your test reports. But then get the other 2 objects. Get your database and get a visualization tool. Get your food, your pantry, and your table. And with this, you're all set to start your data visualization and data-driven decision journey. And start visualizing. There is a good chance that you won't even realize what data is relevant until you face an issue, and then you understand why some data is relevant. And then start digging. Channel your inner dwarf and take a deep look into your output XML file, because that's where the raw data is. Log HTML file is nice to look at, but the raw data is in the output XML file, so dig into that. Find what data is already out there without you having to actually do anything. There's a lot of information for you if you just know how to use it. And then also channel your inner elf and make some time series visualizations about those findings that you have in your output XML file. If the information is not available for you, write your own listeners, write your own scripts, add your own logging, and then harvest that or dig that information and store it in a database and visualize it. I can't really tell you what data is relevant because even Sauron couldn't do it, so I definitely cannot do it. Unfortunately, you will have to do that work yourself. Find the relevant information for you and visualize it. Because who knows what data you will find relevant and will help you make the next big revelation. Thank you.
All right, thank you, Alatsky. Before we get into the live Q&A, just a quick reminder for everyone that's watching in GatherTown of an important setting. So if you're in GatherTown, you can actually turn on quiet mode if people around you are disturbing you and you don't want to hear anyone else. But just make sure when you start interacting with people, you turn that off. So if for some reason you're hearing feedback or audio from other people sitting around you watching the video, you can just turn on the quiet mode. But when you're interacting with another, make sure to turn that off. Right. So quick announcement. All right. Let's go live. Let's do it. All right. Hey, welcome to Robocon.
Hi, nice to be here.
Great to have you. Great session. We have a bunch of questions coming in, so I thought we'd jump right into it. So,
Sure.
first one probably not going to be a surprise to you, and that is 1 second. With the trend of AI and large language models, do you think in the future we will just feed our test results into an LLM that will query it for insights?
It's possible. I have personally not used AI or LLMs in data visualization just yet, or feeding my data into AI, but it's very possible. I don't know what the capabilities of AI are for this because I don't have any experience. But with the uh, rising trend or rising popularity with AI tools, it's very possible that in the future we will just shoot all our data into AI and it will work its magic.
We'll see for sure. Um, can you share some? Do you have any examples of how data visualization has helped identify anomalies or consistency issues in test automation? Or is there a pattern you see a lot that, wow, this actually helps with this type of issue?
Uh, well, at least I mentioned the two stories that uh, the two stories with which helped with the consistency issues. Another story or another example is that once all our tests failed before they were run before 10 a.m. So they failed every morning, and when we ran them in the morning or after lunch, they just passed. Nothing was done, and it was very difficult to see what's going on when we were just looking at the log files. And when we visualized it, we saw that every night when our CI/CD pipeline ran every evening or every night, they failed during the night, and this was simply because the test was run on two different servers on two different time zones. So the dates didn't match when we were making product orders, for example. And it's very difficult to see these things if you're just looking at a single log file. But when you see a bunch of data, the same behavior repeating over and over again, then you can start connecting the dots, and it makes life easier, or it can make life easier.
Right. Cool. Cool. Joshua wants to know, did you ever need to deploy your Grafana dashboard to AWS or a similar cloud platform? I assume that would need to run daily if you did. And was the cost high? Was it costly to do?
We've used only our self-hosted Grafana instances. In my previous project, we did look at AWS managed Grafana, and it was very expensive compared to the self-hosted version. The Grafana, the server was hosted in AWS, but the AWS managed Grafana is very expensive, or was in our case very expensive compared to just hosting the server ourselves. Because it's AWS pricing model that prices per user and whatever and per organization, and we had a lots of different teams that needed their own environments and own everything. So the AWS hosted AWS managed Grafana was much more expensive than hosting it ourselves.
Great. That's a good question. Wants to know, you mentioned tolerance to flakiness for no production. What is your typical policy towards flakiness of tests?
My personal policy is that all tests should always pass. It was not my decision in this case. It came from higher above. But in terms of it was the embedded systems project, and in that scenario, I give a bit more leeway to the actual devices because things can happen because some cable gets disconnected and so forth, or something similar happens, or something accidentally touches the device while you're testing or so. So I give a bit more leeway to the embedded systems project in that sense. But my personal preference is that all tests should always pass. You should make tests so that they always pass.
Absolutely. How did you decide which visualizations or metrics were relevant for making data-driven decisions?
We decided them when we faced issues. So as I mentioned in the very end of my presentation, it's very difficult to predict what will be relevant before it's actually a problem. So our approach was reactive, not proactive. So we faced an issue, then we made the visualization to either validate or verify whether we guessed correctly or try to see could this be the root cause, and then made decisions based on that. We did not magically decide what the relevant metrics were beforehand. We waited until we had an issue, and from there we moved on to making those visualizations with the data that we had collected.
Nice. So I'm thinking no, but I don't know. Peter, well, time for one last question. They want to know, did you try a research report portal? Any opinions or experience?
No and no. So I haven't tried it. I have no experience on it.
Gotcha. All right.
I will Google it, and hopefully I will have an answer in the speaker's corner, but I have no experience yet.
Yeah, it's really cool. Definitely check it out, reportportal.io. If you haven't tried it, definitely give it a look. All right, so those are probably the time we have all the questions. I know you're busy, so will you have time to be on the light side right after this?
Yes, I will have a moment. Then I will be away for a while and hopefully come back a bit later on again to hang around in the Gather Town somewhere.
Great. Well, appreciate the session. It's really an important topic. So thank you so much for sharing at Robocon today. Appreciate you.
Yeah, thanks for having me.
Absolutely. See you later. Cheers.
Cheers.